All right, today we're going to do something pretty cool. We're mapping out the entire universe of the Internet of Things, or IoT. We're diving deep into that hidden architecture that connects, well, pretty much everything, from the watch on your wrist all the way up to the infrastructure of an entire city.
And the answer, of course, is this incredible hidden network that's already reshaping our world as we speak. The Internet of Things. So in this explainer, we're going to get into the nitty-gritty. We're going to look at the exact research and engineering that are building this connected future piece by piece.
So first up, let's map this IoT universe. But before we explore the whole landscape, we need to get our bearings and make sure we're all on the same page with a really clear definition.
So what is it really? At its heart, IoT is all about giving digital intelligence to everyday objects. Think about it this way. It lets a soil sensor on a farm do more than just report, hey, the ground is dry. It lets that sensor automatically trigger the irrigation system, all without a human ever flipping a switch. Now that right there is a fundamental shift in how our digital and physical worlds interact.
Okay, so with that definition in our back pocket, let's look at the what. The tangible real-world applications that are already shaping our industries and our lives. Now, IoT's reach is absolutely massive, but its impact is probably most visible right now in three key areas: the industrial world, our cities, and of course, our personal health. So let's break each one down.
First up is the Industrial IoT, or IIoT for short. This is where a quiet revolution is happening in manufacturing. We're talking about using connected sensors to make these huge gains in efficiency. For example, a machine can now predict its own need for maintenance before it breaks down. Think about that. It prevents incredibly costly delays. That's the power of IoT in action.
Next, let's zoom out to the city level. This whole area is focused on improving urban life for literally everyone. Imagine traffic lights that adapt to real-time traffic to cut down on congestion, or smart grids that manage energy use way more effectively. It's all about using data from connected infrastructure to make our cities more livable and way more sustainable.
And then, of course, IoT has this really direct and personal impact on our health. It's pushing a huge shift from just reacting to sickness to being proactive about our well-being. Your fitness tracker? That's just the tip of the iceberg. The real frontier here is remote patient monitoring, which lets doctors spot issues way earlier and provide truly personalized care.
These applications are, let's be honest, pretty incredible. But they don't just happen by magic, right? They're all powered by a common set of foundational technologies. So now, let's pop the hood and look at the core tech stack that makes it all possible.
All right, part two, the core tech stack. Now we're going to explore the how behind the what, those foundational technologies that are really powering this entire IoT ecosystem.
At the absolute center of everything is data. We're talking billions of IoT devices generating this constant stream of information. So the field of IoT analytics, its whole job is to turn this digital fire hose of data into something useful. It's the science of finding the signal in all that noise.
And this loop here shows us exactly how that intelligence works. It's a continuous cycle. Let's go back to our smart factory example. First, a sensor ingests vibration data from an engine. Second, a machine learning model that's been trained on thousands of hours of data recognizes a pattern that signals a future failure. Third, this generates an insight, say a maintenance alert. And fourth, that alert triggers an action, automatically scheduling a technician. And the best part? This whole process creates new data, which helps refine the model for the future. It just keeps getting smarter.
But here's the thing, right? Sending all that data to some distant cloud server, that takes time. And for split-second decisions, you just don't have that time. You need faster processing, and that's exactly where edge and fog computing come in. A great way to think about it is like your own brain. Edge computing is like a reflex. The decision is made instantly, right on the device, like an autonomous car hitting the brakes. Fog computing is a little different. It's more like a local hub, coordinating all the smart devices in one building. It's all about putting the intelligence exactly where it's needed most.
So, with billions of devices making their own decisions, trust becomes absolutely critical. How do we know the data from a sensor hasn't been tampered with? Well, that's where something like blockchain comes in. It acts like a shared digital notary. Every single transaction between devices gets recorded on this unchangeable public ledger, creating a verifiable history that anyone can check. It basically builds trust directly into the network itself. Okay, so we've got the applications and we've got the tech. But what's the blueprint for building what comes next, and doing it safely and reliably?
The crucial point here is that progress doesn't just happen by accident.
Underpinning everything we've talked about is a rigorous research methodology. This is the formal scientific process that makes sure any new IoT innovation isn't just a clever idea, but that it's also reliable, secure, and that it can scale from a tiny lab experiment to a global network.
So let's connect all the dots on our map. We started with the applications we can actually see and touch in our everyday lives. Then we looked under the hood at the data intelligence, the infrastructure, and the security that makes it all run. And finally, we saw how the whole thing is guided by this rigorous scientific research methodology.
But here's the most important takeaway, the thing I really want you to think about. These fields are not evolving in isolation. The real magic happens where they intersect. What happens when a breakthrough in edge computing suddenly combines with a brand new medical sensor? That convergence, that's where the next wave of innovation is going to come from. So the question isn't just what each piece can do on its own, but which new connection between them will be the one to change our world next.